So let me introduce Haridas, and Haridas is on screen now. And Keerthana will join in shortly as the presentation progresses. They'll be presenting Pic2Card. Over to you, Haridas.
Thanks, Sri. So I'll present my screen. It's visible, right?
It's visible, yes.
Yeah, and I'm clear also, right? My voice.
I have no issues. You're perfectly audible.
Cool. Sri gave you a brief idea already. So today we want to discuss about Pic2Card. This is second open source contribution to Adapticard. It's a Microsoft card generation framework for multiple platforms. Okay, it's a framework from Microsoft. So this is a second contribution. It's like a second open source contribution. Okay, so we'll discuss. This is the agenda we are planning. So we'll go through what it is, what it does, and how it does the internals briefly, and I'll show a quick demo and its internal components. We will discuss. We won't be going too much, but if there is any questions, we can address on that. Based on that, we can go deeper. Okay, so. Yeah, so before going into that, I just introduce myself. I'm Haridas. I'm an architect in Imagineer. So I help clients to solve their data science projects. So joining with me, Keerthana, she's a core contributor to Pic2Card. Okay, so yeah, so before explaining about Pic2Card, so you should it's like a helping the Piccard, right? So I'll give a brief intro about what is Piccard. It's a UI framework that is specifically targeted to the card generate cards. So it will create a widgets, or you can say old names. It creates a cards that schema. It defines a schema actually for a card. This schema is like a JSON format. So this JSON schema can be, once it is created, you can use this JSON payload or that card specification on different UIs. For example, if it is, you can place it on the mobile or some chat application or computer or web application. So wherever the Adapticard client render is available, it will able to reproduce that card in that same fashion. So that's the framework and the specification provided by the Adapticard. So from that, you got a basic idea, right? So here, if you want to develop a card, or why the cards are very important is because so generally, if you look out most of the areas, you can create a snippet of the UI in a card format so that you can reuse as much as possible. So that's a key benefit of that. So Adapticard helps in a nice way. So do it once and reuse all other places. So here, since it's a JSON format, you can what you can do is you can simply write it yourself. That JSON specification, you can write it. So that's a very tedious work. So to make it simple, Adapticard itself providing a simple what you see, what you get like interface. Using that, you can. So quickly, I'll show that. Uh, So this is the interface Adapticard provides. So using this interface, you can design your card. So they provide a set of templates.
Haridas, we are still seeing your adaptive card slide at this point.
Oh, okay. Hold on. I'll reshare. I shared only the application. Right? It's visible, right?
Yeah, it's visible now.
Yeah,
Yes.
so this is that on the Piccard side, you can see a designer. It's a simple what you see, what you get interface to design a card. So here on the left side, you can see different components you can drag and drop, and you can populate this. You can design yourself. So instead of writing the JSON, this is the corresponding JSON it creates. So you can directly write this JSON and create the card, or you can design by using this interface. So, so as a new user, what the Pic2Cards does here is its main contribution or makes it easier here is, as a new user, you have to either you have to see the any of the templates that work fits for your needs, then you can directly use that, and you can play with and adjust and play with that and use it. Otherwise, for example, if the layouts are not fitting, then you have to start from scratch. So you have to take a blank a card, and then you have to place your text or image and layout in a proper way. So that as a new user, it will be difficult and get to you have to work with this. So what Pic2Card does is how we can make it easier by, if you have an image of the card, so maybe you got that image from your designer, or you simply take a screenshot of, for example, you taking a screenshot of this, or some card like interface you are seeing, you like it and you want to reproduce that on your application. We can send that image to the Pic2Card, and Pic2Card will directly generate this JSON with all that specification ready. So that's a what Pic2Card fills in or helps the new users that are coming, who are coming to this Adapticard to play with it very easily. So that's a main contribution, okay, or what we can say main key feature here. So as I mentioned, this is this image slide shows that in a neat way. So you give the image, it will produce the JSON representation. Okay, this is the crude way of showing it. Okay, so let's quickly go into the example. So right now I'm loading it from a PR link. So this is our this contribution is in the final review stage. It's on hold due to accessibility testing. It's going on. The backend side is all done. Front end needed some accessibility test. That's Microsoft side. They are doing it. So once that's ready, that this will be merged into the master, and say it will be available here on this side. So let's on here. Let's see. So when we open this new card, so along with this all other templates, now you have a new option here. Is create from the image. So you click on this. So here you can see a option to upload your card image, or we are providing sample images, a few sample images, so that you can play with. So I'm taking one from this, so and clicking convert to Adapticard. So what here what's happening is that this image is sent to the backend Pic2Card service. That service is running in a Lambda, and then that will convert that to JSON. Once it's ready, it will put it back to this designer. Now you can see that the same image is reproduced here. Now you can edit this image or this block, this text. So and also it reproduce the font size, color, and buttons and all. So this is a JSON it creates. Okay, now the user want do some changes, they can right away do this. So that's a one example. So if you we can try quickly one uploaded option. So this one. So yeah, yep. So here it's produced that this is the one row that it able to get that image, and the text community. It's a proportionally, it's all got that text properly. So for example, if this is the way it looks like actual card, actual image. Okay, so this is the way we are able to produce that. So that's a demo. It's available right now on this link, so you can play with that. It will be soon. We are pushing for this month itself to get into the production. Once pushing for the accessibility test. Okay. So yeah, and the source code is available here, and we will go through that following slides. Okay. So now,
It's just a quick note. We can post the deck on the meetup group after the presentation is done, right?
yeah.
Yeah. Okay.
Sure. So now you see what Pic2Card does, right? Let's see how it is able to do it and what are the components quickly, what's happening under the hood. So this is the main pipeline of the Pic2Card. So you know, right? Say image. We are taking in image. So we need to process the image. So here, what we are looking at the image is we want to look at the text elements, image elements, or radio buttons, and so those blocks we have to identify. So the right model for that is it's object detection. You can see if you heard about this, it's like if you want to detect, if you're given an image, it can detect a person or a bus or car or something like any objects. If you train a model to detect an object from an image or a video, it can do that. So that's the object detection model does. Here, what we done is we transfer learned it to fit into our space. Here, this model will detect the text box, image in image. So since we are giving image, but there is a scenario like this is image again, but here this is the image actually. So this is we have to treat it as image and put it on the produced card. Whatever the final card, we have to treat this as an actual image with rest for the card. Okay. So the object detection model will identify those objects, this text box, image, radio button, and all. Once identifying the sense, it will find that bounding box, a box it will draw around that, and then it will tell what type it is, whether it's a text box, image, or like that. Once that is available, then the all other operation, all other getting the card ready and pre-processing, all that, I mean post-processing, all that done after that. So here there is a key operations like a layout generation. Layout in the sense uh, the model spits out a bunch of bounding boxes and it's type only. So now using that 2D coordinates, you can place it in, you can arrange it in such a way that we can reproduce the layout. So that's what this stage will do. Then the next another part is we are able to reproduce a card with exact text, color, size, font details, alignments, those kind of things we have to extract from that. So that's what the prop extraction will do. So then once all these available, it's internally the core data structure will be formed, and it will absorb that hierarchical structure of these objects, how they are linked, or it can have a row with a column. That column can have a row again. So that nested nature card can have. So those kind of things will be absorbed here, and we'll have a common data set. Once that process is ready, then we will export to a adaptive card representation, or that's a kind of one target exported version. So that's what the overall happening. So to come to the model side, I'll go through it briefly. So we were on the object detection side. There is a bunch of models, maybe even starting from faster RCN. That's one which changed this, which pushed the limits of this space, problem space. And after since that, there is a bunch of models. Even the YOLO, you might most of the heard of. Similar to that, there is other models like efficient dictator. These models are like very efficient in other data sets. There is a common data set named COCO is available. So it's like ImageNet for object detection problems. So on that data set, all these models are measured, or it's kind of benchmark to see how these models perform. So on that COCO data set, these models efficient, that is the better one. But in our case, our data set, the FastRSyn still perform well. Okay. So this is our test data set accuracy, and based on that, I'm saying this FastRSyn was doing good. So if you are not familiar with the object detection metrics names used, it's fine. I'm just keeping it for reference. So these AP, AP50, these are the special metrics used in the object detection space to see how the models performs. So the higher is better here. So the fast Gaussian was doing good, and the deter one is coming close. But it might do well if we increase the more data. Right now we have a limited number of label data with us, so that may be a one limitation. Okay, so as this is the total number of data we have, around 200 images that we labeled ourselves, all the text boxes, radio buttons, checkbox, all that, and then use that to do the transfer learning of these object detection models that are trained already on the COCO dataset. The COCO dataset has 90 class. It's like it has a human, birds, or car, like a lot of 90 objects are there. Those already these models are trained on that. We will take that model and then use our data set and try to transfer learn on specific to this type of objects, only try to detect these objects. Okay, so yeah, we are now kind of, we have to push more on the data set. It will do good, but already it's we are getting a very good result with this data set itself. So yeah, so that's a model side and what's happening. So overall, if you understood, if you are following, you got the actually the model side. It simply gives the this bounding box, and it tells what type it is. The what all the remaining part is handled by this our pipelines, post processing, you can say. So that is where we will do the other heavy lifting, like identify the extracting the OCR, finding the color, font size, font height, alignments, etc. So using that, all these things are formed, and we create the card using all this information. So to explain more about this, I'm handing it out to Keerthana. She will she can handle explain most of this.
Yeah. Hi everyone. I'm audible, right?
Yeah.
Okay. Uh, the next step is the card layout generation. So this is like a key stage in the model prediction flow, pipeline prediction flow right now, because it bridges the gap between the model predicted output to the adaptive card JSON. So like Hari said, model will give us mainly two things. So what type and particular design element is and its spatial details. So here we can see there is some serialized string where it says item of 1 5. So model gives there is an item of type 1. Maybe 1 is equivalent to text box. So with the help of these two details, there are two tasks that is happening parallelly. One is the property extraction. As the name itself suggests, property extraction is nothing but we are trying to extract the design attributes for the objects detected. I'll just give a brief about a few properties. We can talk with an example for the grand buffet spread. There is a text box on top of the image. So first we try to extract the text out of it using tesseract. And for the image, we'll try to extract the crop of the region and take the base64 data like that. And the next property might be the color. For color extraction, what we do is that we crop out the text region and quantize the set of colors in that region to the two most dominant colors, and we get the foreground color out of it. The next property I would like to explain is the font attributes, that is the design size, font size and weight. So this is a quite a tricky property. There were a few challenges in it. Right now, the default approach that we do have is the something called skeletonization approach. So the skeletonization, what it does is like it takes the text region out and applies some image morphological operations on top of it, and it finally brings us outline of for every alphabet that is inside the text box. And by taking the ratio of the alphabet, the area inside the alphabet and to the bounding box, we can bin it to different threshold and get an intuition of the font size and weight attributes. Yeah. The next major property will be like the horizontal alignments. When I The main challenge in this property is understanding how this property affects the entire element versus how this property affects the text inside it. So this was a major challenge here. At the end of this stage, we'll be getting a list of design objects from the model with its property map. And there is another set of tasks that is happening parallelly is the card structuring. So there are two subtasks in this in this step. One is first we have to understand the container details of the object. When I say container, which means whether this object comes under this row, whether it has to be comes under a particular column or not. Here we can see there are three radio buttons, right? So basically there is something called choice set in adaptive cards, where we have to group this radio buttons into different choices inside a particular choice set. So all this is happening in the first subtask. The second subtask is where do we fit this container or an object in the design hierarchy is decided. With the help of a intuitive approach we build with spatial details, we arrange all the elements in its design hierarchy. So at the end of the card layout generation, we get a skeleton of the design where if each and every object will be represented as set of properties and its coordinates. So as a final step in our prediction flow, we simply map every design object to its adaptive card format. We can build the adaptive card JSON. This layout generation pipeline, we can also extend it for different target renderers also, like Android and all that. Yeah, this is the end-to-end prediction flow of Pic2Card. The next up, we have our code base in the adaptive card GitHub repo. Uh, Inside the Pic2Card section, where we have
Sorry, hold on.
yeah, we have all our readmes updated where we can quickly set up the service locally, and also we have command line utilities present, so you can play with it. Yeah, we have our readme updated, so we can you can set up the service locally and try out few models also. When coming to contributing side, can contribute via GitHub by forking and send us a PR. We'll review and merge it. And the next step, you can file bugs in the issue sections also. For the roadmap, like Hari said, the first roadmap we like to do is trying to hit the production in the main adaptive card designer. And we have upcoming layout optimization in, side on the pipelines, and uh, and the font weight enhancements. Like font attributes are like quite tricky ones, so we can enhance it as much as possible to get the most accurate values. And the next step is we have to provide a way to for the user to get the feedback. Like people can upload their design samples to us, or they can tell us what has gone wrong in the particular design sample, like that. And furthermore, we can enhance the model to address the corner cases as well as to add new elements from the adaptive cards. Yeah. Before going on to QA, I'd like to mention our contributors from Imaginia. Um, we have Davakumar, Amit, Haridas, who's spoken with us, and Vasan, and myself. Yeah, we can move on to QA.
Yeah. So any questions we can take?
I have one. Keerthana mentioned that the font weight, there are some tricky issues with font weights. Can you maybe elaborate on what those tricky issues are?
Yeah, sure.
Uh,
Yeah, like the first approach that we used is actually building contours on top of the alphabets. So when I say contour, it will try to connect the edges. So we have to find the edge image edge for each and every alphabet, and we're trying to build a contour on top of it. So when we build a contour, basically edge is nothing but difference in the pixel intensities, right? So when we do that and build a contour, there is a possibility that two or more alphabets can group inside a particular rectangle itself. So which can skew up the entire size and weight of the font. So we did several approaches, and then we have come across this skeletonization approach. Right now, this is the default approach we have.
Yeah, the overall the proportionality. So if you say actually on the card, if the letters look like a bold, so but we have to take care that with respect to other characters in that card, that will vary. If you take a two images, the size of the font in one will be a normal on that, but the other will be, it will be the same size, will be bold. So the relative size we need to take care, that's the one thing. So that to get that relative information about the characters, we are using these methods like the morphological analysis, skeletonization. We are finding that average height of that, then estimating it, and that's a we are putting it into one distribution, taking a histogram, and then taking that bins out of it to get a proper classification of this, whether it is a bold, normal. Yeah. So there is a more improvement iteration we can do, as Keerthana mentioned. So some cases we done maybe 4 or 5 iterations on that. Right now, the best one is the morphological and the skeleton based one. Any other questions?
No other questions. We can move on to the next talk. Thank you, Haridas and Keerthana.
Thank you
This
all.
was a good session.
Yeah.
Thank